every so often with these objective domains for these exams, you get to one that just kind of makes you grit your teeth. And this particular one here on configuring failover clustering is no different. In fact, it's one of the ones that, I don't know, it just makes me irritable because the process of configuring a failover cluster is hard enough. And in this objective domain, it seems like Microsoft is more interested in making sure that you know the edge cases, the one-off cases, the onesie-twosie cases that you'll probably never implement, but you need to know for the exam. So in this nugget, I'm going to do something a little bit different. I'm not necessarily going to focus directly on these, although we are going to touch on each one of these objectives at some point in this series. But I think it's more important for you to understand, first of all, what a failover cluster is, where it is useful, and then how it's configured. Once you understand that, then all of these actually kind of make sense. And then I can show you just the specific little items that you're probably going to need to know for the exam. This is important because building a failover cluster, even today, is probably one of the more complex configurations that you're going to be asked to put together as a Windows administrator. Putting together cluster networking and cluster storage, turning on cluster shared volumes, and even dealing with things like quorum are in and of themselves challenging configurations. This is not just turning on a Windows server. You've got multiple NICs on multiple subnets and different connections to remote and or local storage that you have to put into place. So before we get into these other, again, kind of with the exception of this bottom one down here, these edge cases here, I want to help you through the initial configuration of a Windows cluster first, because everything, again, will kind of fall out as we go. The best way to describe a Windows failover cluster, if you've never really played with it before, is in contrast to the configuration for NLB that we talked about earlier. So we created an NLB cluster earlier, and I had this nice virtual IP up here that we created, and the virtual IP pointed to one of my two NLB servers, so that when my happy little user here ends up connecting in, and he makes his web connection to the virtual IP address, he's going to end up going to one or the other of these network load balancing servers. Now the difference that is really fundamentally important here between an NLB cluster and a Windows failover cluster has to do with the services and where they're located in an NLB cluster as opposed to where they're located on a failover cluster. In an NLB cluster, I'm going to have one instance of whatever the service is that I'm load balancing, in this case IIS. I'm going to have one instance of IIS on each of the cluster members. So if I have a two-node cluster in NLB, I'm going to have two instances of IIS. And that's the idea. I can go here, or I can go here, or I can go here, or I can go here. Different users will probably go in different locations. This is very fundamentally different from how things work in the Windows failover clustering world, because in Windows failover clustering, so here's Windows failover clustering number 1, here's a Windows failover clustering number 2, and I'm attempting to go to a clustered instance of DNS or WINS or a clustered file server or a clustered Hyper-V virtual machine. When that actually happens, and I build my cluster virtual IP up here, here's my virtual IP and network name, here's my happy little user again, and that happy little user attempts to use a clustered resource, well, that clustered resource only exists in one location. If this server should die, then the clustered resource needs to be failed over to the next location, so whatever that resource happens to be. But there's only ever one instance of that resource existing on the cluster at any point in time. The way in which we manifest this is by connecting these machines to one or more instances of shared storage. And it's here again where things get a little bit complicated, because the whole notion of shared storage and failover clustering kind of violates some of the otherwise rules of storage in NTFS. In a failover cluster, you're going to connect your cluster hosts to the same volume. This can be a SAS volume that's connected up through some SAS HBAs. This can be iSCSI or Fiber Channel that are connected up through some remote LUN. In either of these cases, in any of these cases, it has to be shared storage. This server has to be able to see the storage, and this server has to be able to see that storage, because it's the storage where the actual resource lives. Each host is just going through the processing of that storage. So many instances here, one instance here. People can kind of get tripped up here because if you start talking with people, they can talk about the concept of an active-active cluster as opposed to an active-passive cluster. And in an you kind of have to, in your mind, just flush the whole idea of active-active versus active-passive, because in almost every case, a Windows failover cluster is an active-passive cluster. There's only one instance of that resource that exists. There's one special use case that we'll talk about a little later, and that is what's called a scale-out file server cluster, an SOFS cluster. This is a topic for the next nugget, but this is the only instance, at least today, that we have a true active-active configuration in a Windows failover cluster. Okay? So I know there's a lot of words there, but this I think will make a little more sense as we get into the configuration of this cluster, the networking and the storage and all the bits that are required in order to get the cluster up and operational. So here we are back in our demo environment. I have built actually 3 different servers for us to work with to build this cluster. And I've done this because in every single description, every single trading session I've ever gone through for clustering, they always did 2. And I think it's important for you to see the more than 2 configuration, the 3, the 4, the 5, the 8 different 8-way configuration that you can put together. Here is clust 1. I also have clust 2 and clust 3. So 3 different hosts here that we'll be using. I have also configured on each host 3 different networks. And again, I think I mentioned in NLB, we're kind of flush the whole notion that the 2net is for Las Vegas and the 3net is for Phoenix. I just want to use these different subnets and assume that they're in the same data center. Now I've added 3 different NICs to this server. For each NIC, I've configured it, the one NIC on the 1net. This is our production traffic. The 2net is a separate NIC that's going to be used for what is called the cluster heartbeat. This cluster communication is necessary for the cluster to talk to itself, and it's really important that you have multiple different paths for the cluster to talk to itself, because if you ever end up with cluster nodes not being able to talk to each other, it's a very bad day. Clusters don't like it when they can't talk to each other, and you can end up in some weird split brain configurations. I also have a 3rd subnet here that is used for storage. It's always a good idea with a Windows cluster. It's always a good idea with any Windows server, but particularly with a Windows cluster, to separate out your storage into its own subnet and its own network interface card, its own Ethernet card. So 3 different networks, 3 different network cards, and each of these is going to be dedicated to different kinds of network traffic when we build this cluster. I want to show you also that I've done the same thing over here with clust 2 and clust 3. So 1, 2, 3, 3.208, 1.208, 1.209, 2.209, 3.209. So all these have been replicated here, and this has nothing to do with the exam, but highly recommend you kind of match your IP addresses here, especially as you're building these, because otherwise you're going to get completely confused about which addresses correspond with which networks on which servers, and so on and so on. I have also gone through on all 3 servers and added in the Windows failover clustering feature. So not here in the list of roles, but over here in the list of features is this failover clustering feature. And there's nothing to see here because you click it and it installs. And that's all you need to know, because it's the configuration after the install where all the really interesting things happen. I told you, for us to be able to create a cluster, we have to have this sense of shared storage. So here are my 3 hosts up here. And these 3 hosts need to connect to, and I'm actually going to create 2 pieces of shared storage. The shared storage is where all the cluster resources they're actually housed. They're homed on that shared storage. And this is indeed going to be NTFS storage. It is typically basic storage, especially for witness disks. This NTFS storage is where, again, we're going to put the bits that we're going to for the services that we will cluster. And the cluster, one of the jobs of the cluster is to arbitrate who gets access to which pieces of storage that's on here. In the real world, outside of clustering, you would never attach multiple hosts to the same storage. It's not a good idea, because without this clustering layer that sits over the top, the hosts are going to end up corrupting the storage. So you have to be a little careful here whenever you're creating this storage, so that the cluster takes advantage of it and throws its layer of arbitration over the top of this storage. You wouldn't do this in a regular machine or on a regular non-clustered Windows server. A cluster also has to have a secondary piece of storage over here. that needs to be at least 512 megabytes in size. It can be larger, but it has to be dedicated to what is called the cluster quorum. And the cluster quorum is literally just a mechanism for the cluster to determine whether it is still a cluster or not. I like to think of quorum like you ever were in student council in school, or if you ever went to a Kiwanis or a Rotary meeting, or if you ever had any kind of meeting where people had to vote on things. There is obviously the voting that has to happen, but any kind of those meetings, you also have to determine whether or not you have quorum or not. You think about in student council, you don't want to vote on whether or not you're going to spend money on the prom until you know that you have enough members of the student council present so that the vote actually counts. Now, the definition of that is quorum. In most organizations, for quorum to be achieved, you have to have at least 50% plus one of the 50% plus one of the individuals in that organization present before you can even hold a vote. This has nothing to do with voting at all. This is even before you can even get to voting. Now, with clusters, this is the same way. For us to be able to hold a vote on which pieces of the cluster still exist, we have to have a quorum of those members to actually exist. So in this organization, we have one vote, two votes, three votes, and potentially a fourth vote down here that's associated with the disk. Or in fact, it's not going to be this disk, it's going to be this quorum disk here. This quorum disk can be used depending on which of the quorum models that you choose. Now, the different quorum models are present depending on the number of hosts that exist up here in the cluster. If you have an odd number of hosts, you'll choose one model. If you have an even number of hosts, you'll choose another model. Yeah, I told you back in the old days, clustering was a nightmare because there were so many different possible configurations. Well, thankfully, Microsoft now has what is called dynamic quorum in Windows Server 2012 and R2. The long and short of dynamic quorum is that whereas in the old days you had to set your cluster quorum model depending on whether you had odd or even number of hosts, and different again if you had a stretch cluster over multiple different sites, in 2012 and R2 you can just turn on dynamic quorum and let it just deal with it for you. This makes things very easy. So in the production world, you're just going to turn on dynamic quorum. For the test, you actually have to know each of the different quorum models and what they signify. So hold on to that thought for just a second, because this makes a lot more sense once we actually get the cluster built. Okay, I want you to be aware of why we're doing this, and then later on I'll explain what the specific things that you need to know for the exam. We're creating this other piece of storage here because we may need to connect to it depending on the number of hosts that we have. This could be a quorum disk, which is a network or directly attached disk, or it can be a quorum file share that sits on some file server somewhere. This is called, over on this side, this is called a witness disk. So on one side I have a quorum disk I'm attached to via SAS, iSCSI, or a Fiber channel. On the other side, I have a witness disk that is literally just an SMB file share that exists somewhere in the world. All right, so hopefully this has not confused you. If it has, don't worry, because it makes a lot more sense once we start getting into the actual configurations. Let's now go through the installation of this cluster. And for us to be able to do that, we've got to go through a couple of steps first. The first of which is for us to actually connect up each of the individual hosts to the couple of iSCSI LUNs that I've already provisioned over on our file server for this purpose. I want to show you that I've already gone over here to the Discovery tab for each of these three hosts and configured the three hosts to plug into 1.204. That's our file server, so that we have an open connection now between each of the cluster hosts and the file server. Over here on the file server, I also have provisioned all the necessary disks and volumes and storage pools to create two different iSCSI virtual disks that will provision out to our cluster hosts. This is exactly the same process that we went through when we were talking about provisioning iSCSI virtual disks in a previous nugget. So let's come here to our new iSCSI virtual disk, and you'll see there's my 1 gigabyte LUN, or what I'm about to create is a 1 gigabyte LUN. And here's a second volume that I'm going to use to create my 512 megabyte quorum disk. I'll start here with the one, actually that's a 1 terabyte LUN, not a 1 gigabyte LUN. I'll start with the 1 terabyte LUN here that I'll call iSCSI-LUN, let's call that LUN 3, for example. With that, let's call this next. I'm going to set it to the entire size, which is 1 terabyte. And I'll make it a dynamically expanding disk here. And I'll set up new iSCSI targets. iSCSI lun, dash lun 3. Choose next. And then add in all three of these initiators, clust 1, clust 2, and clust 3. So I'm going to share the access to this LUN across all three of these individual iSCSI initiators. Choose next. I'm not going to enable chat because I don't want to deal with that complexity here. And you'll see, boom, we are now provisioning this LUN so it's going to be available for all three of these servers. I can do the same thing also if I want to come down here and create the additional connection for what will eventually be my quorum disk. This is this smaller disk. Notice how it's just about 1 GB in size. Call this iSCSI-quorum disk. And I'll copy that because I'm going to need that in a minute. Choose next. I'll give it the full size, 934 megs, although it only needs to be 512 megs in size. That's the minimum size that it needs to be. I'll set that up to some new iSCSI targets here. Again, iSCSI quorum disk, and I'll connect it just like I did before to all three of these cluster servers, 1, 2, and 3. I can't stress enough that in a world where we don't have clustering, that you're just not going to connect up multiple hosts to an iSCSI disk. There is no arbitration between hosts to ensure that they don't overwrite each other without having that clustering layer in place. But since we do have that, we can do that here. All right, so I got two LUNs here. Nobody's connected to it, but I got iSCSI LUN 3 and my quorum disk. Let's go back over here to my cluster now and make the necessary connections. Remember the old trick, start at the left and move your way to the right. So if I have done everything correctly, I should be able to refresh this and see the new discovered targets that I provisioned over on the file server. Oh, there they are. So here is one called pseudo target. Here is one called lun3, and here's the quorum disk that we've created. And now we need to make these active here on this machine. To connect to these LUNs, I'm going to click over here under the connect button, and I'm going to go to the advanced, and I'm going to make sure that I set up the appropriate initiator IPs and tag them to the appropriate target portal IDs. Remember, I got multiple different IP addresses on this machine because I got 3 different NICs. The 3net is the network that I've set up as the storage network. So I got to make sure that I set this 3net connection to the 3net connection on my file server. I should mention that I also added another network to my file server and another network card. So I'm going to keep everything on the same subnet so that I don't have to cross subnet boundaries. Just a good design decision. Makes things much easier for you and your network team, and you don't end up having to lose any performance because you're having to cross through routers. Okay, so there's our 3net connection. And if I click OK here, that should connect us up. Yep, there we go. Let's do the same thing now for our quorum disk. I'm going to hit advanced and make sure that the iSCSI connector is going from 3207 to 3204. So there, now we have those two connections. I'm not so interested in this LUN1 right now because I'm only interested in LUN3 and the quorum disk. So that should be the 3 connections that we have. I need to repeat the process now over here on the other servers. So you'll see that I have the discovery, the target portal set up here to my file server. Here's 3.204. And if I hit the refresh button, I should see those discovered targets. There's LUN3 and there's the quorum disk. So just like before, we're going to come up here and make those connections to 3.208. Remember, it's a different IP address here because it's a different server. And complete the process on the quorum disk as well. So bam, bam, and bam. Do this on each of the hosts that you plan on bringing into this environment. And in fact, I almost forgot. If I come back here to cluster 1, I almost forgot to go through the other steps in the process, which is under favorite targets to just refresh the favorite targets and then auto configure the new volumes. So don't forget these other 2 pieces like I just did. Favorite targets, refresh, volumes and devices, auto configure. Okay? Let's do the 3rd server here. Okay, we're going over to our iSCSI initiator. We've already got the target portal set up, so let's refresh things. Make sure that we can see the targets appropriately. Yes, we can. And then connect to those targets. So iSCSI initiator 3209 and 3204. And then repeat the process again. So sorry to go through this. I know it's a long process to go through, but I think it's valid for you to just see the many times that you've oops, did that twice. The many times that you have to go through this, and you have to do everything perfectly every time, or you're going to end up with some very odd configurations. If everything goes correctly, we should see again favorite targets and the volumes and devices appear here. So what have we done? We have now extended this LUN, these two LUNs, so that they're available to all three of these servers. If I take a look at disk management now, disk MGMT, I should see these three LUNs now appear in the list of those that are available for these three servers. So you see here disk 2 is the large one and disk 3 is the small one. Next step in the process is to bring these different LUNs online. You'll notice I'm doing it on one of the hosts here, and I'm not going to touch it with the other two hosts until we get that cluster arbitration layer put into place. So I'm going to bring them online, and I'm going to initialize the disks. Let's do this as a GPT this time. I'll click OK. So that's initializing this disk as a GPT disk. It has to be a basic disk. For me to use the native disk support that's included with failover clustering, I have to use a basic disk here. Let me create a simple volume. I also need to ensure that this volume is formatted NTFS. Has to be formatted NTFS if I plan on using CSVs. So let's call this cluster volume 1 and just format that as a cluster volume. Down over here while that's doing its work, I then also need to make sure, again, a basic disk and set this up as an NTFS formatted volume. We'll set this up as cluster quorum. A lot of times people will set this to a different drive letter if they want, like the Q drive. Quorum drives don't actually have to have drive letters these days, which is a nice new feature because in some situations, back in the old days, you'd actually run out of drive letters, depending on how large your cluster was. So here are the two volumes we've created, NTFS and BASIC. These two volumes have been configured here on my first server, and they've not yet been touched by Cluster 2 and Cluster 3. Highly recommend you don't touch them until after you get that cluster layer put into place. With our storage now configured, we can now go to the Windows Failover Clustering Wizard and Cluster Manager here and validate the cluster. This process is really important because it helps ensure that we've done everything correctly in all these preparatory steps to ensure that we have a cluster that's ready to actually be clustered. Back in the old days before cluster validation, you could actually create a cluster that didn't really work. It looked and smelled and felt like a cluster, but it didn't actually work. This cluster validation wizard definitely ensures that you don't end up with that very weird situation. I'll choose next here. We are going to cluster together the three servers, clust1, and clust1, and clust2, clust2, and then clust3. Those three machines, 1, 2, and 3. You may end up with a situation where this process of validating the cluster node takes a really long period of time. If it does, that means you haven't done something correctly. If it happens as fast as it did here, then that means you've done things correctly up until this point. There are a variety of tests that happen as part of the Validate a Cluster wizard, and you can choose which tests you want to run. There's a whole bunch of them here, lots of them that are done. I would recommend, at least your first time through, to have it run all the tests. If there are any warnings, any cluster preventing errors, you're not actually going to be able to create that cluster. You may actually get a couple of yellow dot warnings depending on if you've set up things inappropriately. We'll see if we've done everything correctly. It's possible that we may get a couple of yellow dot warnings that we can just ignore, or we can rethink our cluster design. I'll choose the next button here to run all the tests. And when I hit the next button again, I'm going to pause the recording because running these tests can take a pretty extended period of time. When we come back, we'll see how we did, see if it's okay for us to build that cluster, and then go about the next step in creating that new cluster. And we're back. So you can see here that the report has completed. Each of the three nodes in the cluster have been validated. Testing is completed successfully, and the configuration appears to be suitable for clustering. I love the hedging of the bet right here. If I view the report, you'll see just the level of detail that this cluster report actually goes through. There's a whole variety of tests. I mean, this report is extremely long here. And what it does is it gives you a nice review of what the results are of all those variety of tests that it concluded with. We got one warning here. So if I troll down here to the network and then take a look at what the warning is under validate network communication, it looks like, one of the cluster nodes had a more than average packet loss from one of the other cluster nodes. This just gives you an impression of the level of detail that Microsoft has put into making sure these clusters work at this point. Like I got to tell you, before we had this, it was a lot more difficult to get clustering up and operational. But other than that one little kind of minor warning here, there's nothing that's going to prevent us from actually clustering this host. So let's go through the next process of actually creating the cluster using the validated nodes. This next wizard is exactly that. That's the create cluster wizard. And if you go through it in this order, you don't have to go through the validation process a second time. Let's give our cluster first a name. This cluster name is the name that you'll use for administering the cluster. And it's also called the administrative access point. Now I want to pause here just for a second because I want to show you one of those oddball cases that you have to know for this exam, and that is right over here, the configure clusters without network names requirement. Because it is this access point that is in this wizard, it gets created as an Active Directory account, an object in Active Directory. Now, when you're creating a, quote, a cluster without a network name, what you're in fact creating is what's called an Active Directory detached cluster, which is here. An Active Directory detached cluster is one that obviously doesn't have a network name, and it is a relatively rare use case. You will use it in situations where you do not have the required permissions for creating computer objects in Active Directory, or you need to, or even the ability to pre-stage that account in Active Directory. So if for some reason you don't have the ability to create that account for the cluster name, the cluster name object here, well then you can create an Active Directory detached cluster. I don't know why this use case exists, because you would think that the people who are doing clustering would talk to the Active Directory people. I just don't know. Okay, so when you do that, just be aware that many of the cluster workloads are not recommended or even not supported whenever you're creating an Active Directory detached cluster. BitLocker is not supported. Clusterware updating is not supported. You can't copy a clustered role between failover clusterings that use different types of access points. You can create it only whenever you create the cluster. You can't change it later, and you can only deploy this using using PowerShell. There is no way to do it using this wizard that we're looking at before. So here is the PowerShell command that you'll need to do in order to create this Active Directory Active Directory detached cluster by setting up the administrative access point only in DNS and not in Active Directory as well. So again, one of those kind of weird use cases here for creating clusters, but I got to point it out because it is potentially one of the exam questions. We are, and in your case, you are probably going to create a traditional Windows cluster just because you'll have access to create these accounts in Active Directory. So let's call this cluster, let's just call it cluster 1. Okay, something very simple here. And for that cluster name, we're going to need to identify one of the addresses that we can use or associate with that cluster name. Now I told you that we have a kind of a production network here. We have a heartbeat network, a private network, and then we have our storage network. So we don't want to use either of these two networks as the location for our cluster name. We do want to use the 1.0 net address. I also have to plug in another IP address that's going to be associated with this cluster name. So similar to that virtual IP that we were talking about when we created an NLB cluster. This just needs to be one that's available and not used by some other machine. So I'll use 1.221. I'll choose next. We will go through the confirmation screen here. If everything is good, then we'll go about actually creating the cluster. Now I'm going to not add the eligible storage to this cluster because I want you to see what the actual add storage process looks like whenever you have a cluster in place. So I'm going to create the cluster without the storage just for now, and then we'll add the storage as the next step in the process. I'm going to choose next here, and unlike the validation process, the actual creation process doesn't really take that long. You can see that we're going through a couple of the different steps here, adding it to Active Directory, creating the cluster, making sure all the nodes are online, all those different things that create this cluster out of 3 different hosts. I'll just finish here, and if everything is right, then what do you know? Check it out. We have a functioning cluster here. There's cluster 1, and I have the 3 different nodes. There's node 1, node 2, and node 3. There are no roles associated with this cluster because we haven't created anything on top of it yet. Nor do we actually have any storage here because we decided not to pull that storage in as part of this cluster creation. Now, I did that for a couple of different reasons. One is because I wanted you to see what happens whenever we add a new disk, but also because I wanted you to see the difference here between storage pools and the disks that we have provisioned here to the nodes in this cluster. And this actually relates, let me back up here just a second. This relates to another of these topics that's here called add or configure storage spaces. So when we're creating clusters, as I mentioned, we've got this virtual IP up here, and we've got 2 or more hosts generally that can sit below that virtual IP. And the important part about these clusters is that they're all connected up to some sense of shared storage. I also told you that shared storage can be one of a variety of different types. It can be SAS, or it can be a LUN that is provisioned from either iSCSI or a fiber channel. So either one of these is a remote LUN. About the only thing you have to know as it relates to configuring storage spaces and clustered storage spaces is the recognition that a clustered storage space is connected to via 1 or more SAS HBAs. This is locally attached storage that is connected up to each server individually. Okay, locally attached. It is non-RAID, so you cannot have RAID in the case of storage spaces. They have to be SAS disks. They have to be locally attached SAS disks, and you cannot use any kind of remote storage in order to do a clustered storage space. The other thing you have to be aware of with clustered storage spaces is, and if I pull up this other little website here, is that a minimum of 3 physical drives with at least 4 gigabytes capacity of each are required to create that storage pool in a failover cluster. So these are the requirements here that you just got to be aware of when it comes to those clustered storage spaces. Again, this is one of those configurations you just don't see all that often because the clustered storage drives, the JBOD drive enclosures that you'll use for these sorts of things are relatively small in number, the ones that are actually approved for use by Windows clustering. So again, I would know this for the exam, but for most production clustering configurations these days, you're probably going to use your classic storage area network. It's just the more simple of the solutions, and you don't end up having to buy a fixed use, just a bunch of disks enclosure that you'll only use for the purposes of the cluster. All right, so that is the clustered storage space here. Let's actually go about adding in the disk that we need to add in so that we can host some clustered resources. I'll right-click here on the disks and choose to add that disk. You'll see here are the 2 cluster disks that we have, one of which is the one we think of as the quorum. The other one is the cluster disk that we use for all the other things, the terabyte-sized one. And I choose OK. Boom. Very easy process because we've gone through all that effort prior in getting the proper configuration set up via iSCSI. Now, one thing you need to know, however, when you're adding in these disks, is that there are actually 2 different ways in which a disk can be presented to a cluster. The cluster can recognize a disk as available storage, or the cluster can recognize the disk as what is called a cluster shared volume. Cluster shared volumes were actually a really awesome improvement that was added to Windows clustering back in 2008 R2. And they're designed to get around an early limitation with how storage was considered in the clustering model prior to 08R2. So back again to my boxes on paper configuration, and here is my large piece of storage. If I create and provision this one piece of storage to 3 hosts as available storage and not as a CSV, only one of the hosts can actually make use of the storage at a time. So if this very large, 1 terabyte piece of storage is associated to the host clust2, for example, well, then only the resources on clust2 can make use of all the items that exist here inside this terabyte storage. The problem here is that The only way I can get multiple different resources to operate on a cluster at the same time is by adding all kinds of new LUNs that can be additional pieces of storage out of my storage area network. This got to be particularly challenging when we started dealing with things like Hyper-V. With Hyper-V, every single virtual machine sitting on this volume, when it's configured as available storage, migrates at once. So this becomes cluster 2 or cluster 1 or cluster 3, but every single virtual machine had to migrate at the same time. That got to be a little complicated because we want to be able to have a little more granularity in migrating our virtual machines. Well, a cluster shared volume is one that takes this volume and allows you to chop it up into smaller bands of storage. And each individual band of storage can be addressed by individual cluster hosts without having the entire piece of storage have to go to one host at a time. This is accomplished through the use of VHDs inside the storage, and multiple different VHDs can be on this volume. Each VHD can be owned by one of the nodes. It just greatly granularizes where different resources can be associated once we build these clusters and start adding things like virtual machines and other resources to it. So if I want to use a piece of available storage for much more than the very basics of things, if I want to start doing lots of different things with this very large volume of storage, what I need to do is change it from available storage to one that is a cluster shared volume. Notice how it goes offline. It does the conversion, and then the volume then comes back online as a cluster shared volume. That's all there really is to see. This becomes more important as we begin to add roles, which we'll talk about in the next nugget. Things like Hyper-V virtual machines and DNS roles and WINS roles and all the different roles that a cluster supports. I would be aware of the difference between a cluster shared volume and available storage, and the fact that you need to upgrade available storage to cluster shared volumes if you plan on needing to run multiple different resources from within the same volume across different clustered nodes. So all right, we've got our storage set up here. Let's come down over here to our networks and take a look at the available networks we have. Now recall that when we configured this, we set up 3 different networks. We had a 1net, a 2net, and a 3net. So 192.168.1.0.2.0 and .3.0. The 3.0 we've configured specifically for storage. The 2.0 we've configured for the cluster heartbeat, sometimes also called the private net. And the 1.0 is our production net, or the public network. Now, in order for these hosts to be able to maintain their quorum and ensure that they can still talk to each other, they actually need to have, in the best practices configuration, more than one path to talk to each other. My 1.0 net is the network that I'll probably end up connecting up to the rest of my network. My 2.0 net is a private network that provides a secondary path for these machines to end up communicating with each other. That heartbeat absolutely has to function, and so it's very important for me to set these things up so that I can run the cluster communication over more than one path, and the client communication over whichever path is most appropriate for clients to begin to talk. In my DNS, when I create virtual machines or when I create DNS services or any of the other cluster roles, I'm probably going to set them up to a 1net connection because that's my production server net, and leave the 2net connection purely as a private network that's not really addressable by other people outside the data center. The way in which I do that is by configuring the networks. For each network, I need to identify whether that network is going to be used for cluster communication and or for client communication. So let's see, our cluster network 1 is the 3.0 connection. So this is actually our storage connection. And our storage connection, we don't want any kind of cluster network communication on that storage network at all. We want to just dedicate that to storage alone. So let's set that up. Let's then set up our cluster network 2 here, which is our 2net. This is our private or our cluster net. So let's call this heartbeat, and we'll set this up as allow cluster network communication, but not client network communication. We don't want our desktops to be able to talk to the machines over this network. For the third one, we will reset this now to be our production network. and we will allow both cluster network communication and client network communication to occur over this network. So that's pretty much what we're configuring here. We want to make sure that we divide these out so that each one is used for the most appropriate ways. Because trust me, the last thing that you ever want to have when you build a cluster is to have the cluster lose communication with each other. That ends up creating one of the worst of possible days. The next thing I want to talk about is the quorum configuration. And I talked a little bit about quorum in a basic sense, but I want to show you the couple of different quorum models that exist here once you get the cluster built. So let's take a look here under More Actions so that we can configure the cluster quorum settings. Under here, you'll see that we have the start page here, and it's here where we can determine what kind of quorum configuration we want. I mentioned with the release of Windows Server 2012 that we have this new dynamic quorum configuration that will just take care of all the real complexities, the details on our behalf. And in a production world, whenever you're deploying this out in the real world, the default quorum configuration lets the quorum or lets the cluster handle most of the work for you. And that's really how you just want to set this thing up. For the test, however, you may want to determine, or you're going to need to know, what the various advanced quorum configuration options are going to be. It's a very common exam question. A cluster can determine its quorum in one of 4 different ways. And each one of these we think of as a quorum model. Let me cheat a little bit and bring up a website here so you can see where you can find this on your own if you want to research it a little deeper. There's a website here that relates to Server 2008 and R2 called Understanding Quorum Configurations in a Failover Cluster. For the test, I'd be aware of the high-level configurations and where they apply. For your own, if you're interested in it, there's actually some very detailed descriptions as to why these quorum models exist. So remember, the point of quorum is to determine if there's enough of the cluster still running so that the cluster can actually consider itself to be a cluster. Just like with your student council, do we have enough people here that we can have a vote on spending money on the prom? Are there enough resources up and running that we are actually a cluster? So there are 4 different possible options: node majority, node and disk majority, node and file share majority, and no majority. Of these 4, the last one down here really isn't a model at all. It's actually not recommended because there actually is no majority. You're only looking at whether or not the disk is there or not. The disk becomes the only vote. And if the disk goes down, the cluster in its entirety ceases to exist. We're not talking about failover, we're talking about every single resource in the cluster ceases to exist. So we don't want to do that because this configuration creates a single point of failure. If we lose the disk, we lose the entire cluster. The main difference in when you're configuring clusters is whether or not you have an odd number of nodes versus an even number of nodes. Now I've configured this cluster with 3 different nodes, so that's an odd number. In node majority, the only objects in the cluster that have a vote for determining quorum are the nodes themselves. So in a 3-node cluster, I have 3 votes. I can alternatively turn on node and disk majority. So in a node and disk majority configuration, this is for even number of nodes. But in a node and disk majority, I end up having each node has a vote and the disk has a vote. Now let me stop and let's think for a minute as to why we have to have these different kinds of quorum models for determining whether or not we've hit quorum or not. In a situation where I have an odd number of nodes, like 3 hosts, let's call it where I have some network partition that occurs. So there's, one host over here that's somehow isolated from the other 2 nodes over here. Maybe it's not down, but maybe it is just isolated. In this situation, each of the nodes in this cluster can recognize whether or not it is part of the surviving half of the cluster. Right? So in this case where I've got this partition, this node isn't necessarily down. He thinks he's the only node still running. These guys also think they're the only nodes still running because he's not down, he's just got some sort of weird partitioning that's happening that's preventing them from talking to each other. In that case, because I'm using node majority, the single node will recognize that he is no longer the cluster anymore. There are not enough resources for him to actually function, and so he will cease to exist as a node in the cluster. The two surviving nodes will continue to operate because they see themselves as having the majority stake in the cluster. The whole point here is to eliminate the situation where I could have, for example, 4 hosts like this, and the partition to occur right here. Think about this problem for just a second. Let's say I end up in a situation where, for some reason, 2 of my nodes get separated from the other 2 nodes. In that case, each of these nodes believes themselves to be still operational. They know that the other pieces have gone down, but they know that they're operational. You got 2 nodes over here, they're exactly 50% of the cluster, and 2 nodes over here that are exactly 50% of the cluster. Which one of these, this is the question I'll ask you, which one of these 2 halves is actually still the cluster and which one is the failed half? It's impossible to know. So for this reason, we have this other configuration called node and disk majority that adds the disk as a 5th vote in determining who still exists as the cluster. So if my partition exists here, I have a 3rd vote, 1, 2, and 3, so I can identify that these are actually the failed half of the cluster. So again, complex configuration here, but thankfully Microsoft has incorporated this dynamic cluster configuration. The real problem happens not whenever you build the cluster, but when you add an additional node here and forget to change your quorum configuration. That's a really bad day. The third of these is what's called the node and file share majority. And this used to be for what is called here for clusters with special configurations. But these days you can alternatively use a file share or a connected disk as that final vote. The node and file share majority is just like the other configuration. So I've got 4 hosts here, except instead of them all being connected up to a single disk like they would be, I can have a separate file share that sits on a file server somewhere. And when all these talk to that file share, all those can use that file share as the remaining vote, the additional vote. So the idea is the same. The notion is the same, that there is an additional vote here to break the tie. But it's just, where is that tie breaking vote located? Is it located on a connected disk? Is it located on a file share? The reason why we have this additional configuration will make more sense when you start talking about multi-site clusters. So situations where you have a 4-node cluster that happens to be in 2 different geographic locations. So here I've got 2 nodes in Denver, and here I've got 2 nodes in Las Vegas. For this configuration, obviously I'm not connecting up these 4 hosts to the same shared storage. No, I got to have some kind of replication of storage between these 2 sites. Well, in that case, it doesn't make sense for me to use the node and disk majority because I need to have some additional file share that exists out there somewhere else on the network to break the tie. Now, this is going way over the top in terms of complexity, but in this multi-site environment, actually this is just kind of a little Easter egg for you, but in the multi-site environment, the best configuration is actually to put the file share in a completely separate site. So, for example, Phoenix. And the main reason why you want to do that is to protect yourself against the loss of an entire site. So, let's say somebody nukes Las Vegas. Well, when that happens, it's nice to have this file share that exists in the 3rd site so that Denver knows it's got the ability to talk to that file share to determine that its cluster nodes are still surviving. If I happen to put the file share over in Las Vegas, well, then I'm out of luck because I've lost both the witness and all the nodes. So again, pay attention to these quorum configurations because you're going to need to know what they are for the exam. They used to be here in the quorum configuration wizard. They used to be spelled out directly. You would choose node versus disk and node and file share. But now they're actually set up a little different, so it obfuscates the names of these different quorum configurations. It is here where I can actually select what is called now the voting configuration. So how many nodes do I want to configure in my cluster? All of them, select nodes, or no nodes at all. This no nodes configuration corresponds to the quorum that we talked about here, no majority, disk only. The other configurations are done here by selecting all nodes or a set of nodes. If I were to select 2 nodes, well, then I would need to then identify what the quorum witness is going to be because I have an even number of nodes. That can be a disk witness, which is the disk witness we've configured here as our cluster disk 1. That's the small disk, so the 512 megabyte disk. Or I can set it up as a file share witness, which would be literally a file share that exists somewhere on my network. If I don't have that, I can come back here and select all nodes and then make the same configuration. Now you may be asking, well, wait a minute, if I've already got an odd number, why would I make the configuration here? Remember that Microsoft is setting this up as a dynamic model. And so by configuring which of my, whether I'm using a disk or a file share here as the witness, allows Microsoft to adjust which model it uses on the fly. So you absolutely want to, when you finish creating your cluster, come back here into the quorum wizard and identify if you're going to use a disk or a file share witness as that option, so that the dynamic nature of the dynamic quorum model can actually switch back and forth as to whether or not it applies that vote in the right location or not. I'll choose the disk witness here because I've created one, and I'll set it to that cluster disk 1, which is the small volume that we created. I'll choose next, next, and there we have successfully configured the quorum for this cluster. All right, so we're getting really close at this point to having this cluster up and operational and ready to host clustered resources. But we got two more topics that we have to talk about, one of which you're going to want to implement probably before you put the cluster into production, and that's cluster-aware updating. The other one you just need to be prepared for should you ever need to upgrade a cluster. The main thing you got to be aware of when it comes to upgrading a cluster is that there really isn't a way to directly update a cluster. I just love the verbiage here. I'll show you how you can actually get around that limitation here in just a second. Let's talk about updating a cluster. Right, so the whole point of a cluster is that your services never go down. Right, you create a cluster because you want very high availability for your services, but Microsoft still releases updates on an every month cycle, or almost every month cycle. So wouldn't it be nice if there were some way in which you could deploy those Windows updates to individual cluster nodes without having to go through the process of moving resources around and one at a time implementing the updates, installing them, and rebooting the box? Well, there are a couple of ways in which you could accomplish that. There's some nice automations these days. One of which happens here under Server Manager. If I take a look at the cluster object, I can right-click and choose to update the cluster. Now, obviously, I've got to have my WSS infrastructure up and running. I've got to have updates that are approved for deployment, and all the bits that are necessary to just simply invoke the Windows Update agent for this to function. This will, in fact, go about updating the cluster and will follow some of the rules that are necessary to do it successfully. But what you probably want to do is turn on a little bit more automation so that you can more granularly control the ways in which your cluster ends up getting updated. That you can do by turning on what is called cluster-aware updating. So where you do that is actually here back on the cluster object under More Actions and then Cluster-Aware Updating. So obviously, again, I'm going to assume that you've got all the necessary connections into your WSS infrastructure. You got all the, your IE configurations are appropriate, your proxy configurations are appropriate, so that everything is set up so that those machines can talk to their WSS server or even Windows Update. In order to turn on cluster-aware updating, you'll want to turn on what is essentially a cluster-aware role that can manage the power off and power on activities of the different nodes here. And that is done here, that's started by clicking this Configure Cluster Self-Updating Options wizard. What you're going to do is enable a clustered role, so literally a resource that you add to the cluster, with the job of managing the updates to that cluster. Doing so is going to require the addition of a new Active Directory object. If you need to have a pre-staged computer object that's already available in Active Directory, you can click that here. I'm just going to create one because I have the necessary privileges to accomplish this. I need to identify what this schedule will be. So do I want to do it monthly, daily, weekly, however often I'm interested in doing it. And then I have a variety of advanced options that I can set up for that. What's my timeout? Is there an order for the nodes that I want to actually reboot them in? Is there a pre and post update script that I may have hand coded or created myself in order to do that? How many retries per node? And all these different configuration options that help me customize the process of updating this cluster. These are all available here under advanced options. Under additional options, I can determine whether or not I want to choose recommended updates in just the same way I do the important ones. One assumes that if you're plugging this into a WSS infrastructure, you've already got those approval configurations set in WSS. But this is really determined if I'm connecting directly up to Microsoft via Windows Update. When I choose Next again and Apply, that's going to go through the process of adding that clustered CAU role for managing all of this process. Now, this is going to go through, adding the role here and accomplishing some tasks. But what I really want to show you is that over here in this list of cluster actions, this is the location where you can manually apply updates to the cluster, preview what they might be, or adjust that run profile that we configured just a second ago. Also, I would recommend running this Analyze Updating Readiness prior to going through this wizard, just so that you can make sure you've got all the configurations set. Just like with the cluster validation wizard, there's a very long list of tests that it's going to run. It takes a while for that actually to go through its process to ensure that you actually can update correctly and you're not going to end up with any kind of cluster split brain situation going on. So this is the concept as it relates to cluster aware updating. Hopefully we've gone through and completed the addition of our clustered role. This also gives me the opportunity to show you what this role looks like once it gets created here in the roles node. Or perhaps not, because it's not available here. I would be aware, this actually reminds me, I would be aware too, and I know I've said this 1,000 times now, but these PowerShell commands, Microsoft just loves these PowerShell commands. There are a bunch of PowerShell commands here that are associated with cluster aware updates. If I do GCM where name like CAU for cluster aware updating, there's a whole bunch of these cluster aware updating commandlets that I would just be aware of, like this one. So invoke CAU scan. So that would take me through the process of actually, invoking the scan. If maybe I need to go and add a new cluster role here, well, add CAU cluster role. That would add in essentially what I just attempted to do here, except through PowerShell. So know what the mapping is between these commands. There's probably some other cluster ones here too. Those are associated with clustering. They're common test questions. Okay, just know again what these kind of really are. The very last topic we have here for this nugget has to do with migrations and upgrades. I already told you that there really is no direct upgrade process. There's no rolling upgrade process for Windows failover clustering, but don't fret, because rather than doing a rolling upgrade, which if you think about all the dependencies here in the clustering world, the failover clustering world, that could be a real nightmare. So what Microsoft has somewhat intelligently done is instead focus not on a direct upgrade path, but instead a migration of the clustered roles that you've created onto that new version. This is a way better approach, even though it requires a few extra steps, and it requires that other cluster to be in operation and up and running before you can move the roles. So you kind of have to have extra hardware to do this. Here under More Actions, you'll see this link here called Copy Cluster Roles. In previous versions, this is actually not called Copy Cluster Roles, it's called Move Cluster Roles, or actually I think it's Migrate Roles. This Copy Cluster Roles wizard helps you copy clustered roles from clusters running Server 2012 R2 or previous versions. This is the process by which you go about attaching to the old cluster, figuring out which roles you want, and then copying them here into this local cluster. That's about all you need to know. There is a wizard. There's obviously PowerShell command exposure for this, but there is a wizard here, and it's focused on the roles as opposed to a direct upgrade path. So, a lot of content here. Sorry to melt your brain, but as I said, failover clustering is a very non-trivial activity, and setting it up is a lot of hard work. I highly recommend documenting every step in the process because it is very easy for you to get screwed up your networking and storage settings, and perhaps what your quorum settings may be as well. What did we talk about in this nugget? We talked about how to set those up, how to build a cluster, and all the steps that are necessary to bring it into operations. We talked about these three items, networking, storage, and quorum, how you can turn regular available storage into shared volume, clustered shared volumes, how you can create an Active Directory detached clusters, or here one that is called without network names, how storage spaces are used anytime you've got DAS that are set up as SAS disks, locally attached to each host in the cluster, the upgraded cluster topic and how it's focused on the role migration, and then how you can turn on cluster aware updating to ensure that the whole process of dealing with the monthly patch cycle is not as big of a deal as it might otherwise be. Coming up next, we are going to assume that with this fully configured cluster, it's time now for us to implement some cluster roles. We'll look at the different roles that are available, how to get them installed, and then also how to tailor them so that they're moving around, they're bouncing around between cluster nodes, happens in a way that we can predict. That's all the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.